Now in the previous video we're talking about arguments to main, and we're able to explain clearly what is actually happening there. Now today we'll actually continue. We're talking about void arguments, and we're also looking at string input with functions. Okay, so let me just quickly go to my shell here. Now in this was a program we actually wrote in the last video. Now right here you could see that I'm actually using all parameters or variables rather I declared: AC, AV, IDX, MSJ. I'm actually using all of them, though this line here, this particular line here, is commented out, but then you could see I'm actually using AC here. Now if I decide not to use, because I can actually achieve this same condition here, this same one here, and just press I to enter my inserting mode. You can actually achieve this by doing this IDX. I can actually achieve the same thing by just doing this, and my program is going to work fine. Now immediately I do this, if you realize that I'm no longer using AC anywhere in this my program, because here it's already commented, so the compiler is just going to ignore it as though it is never there. Now here also I'm not using, there's nowhere inside this program here till it hits here that I'm actually using the AC variable. Now if I'm going to compile this using, okay, let's just see it. So if I'm just going to compile this now using you have to use using those gcc where the flags. Now it's going to give me an error of an unused variable. Sorry, this is actually a small a here, and then there's no v. Yeah, you could see it actually was giving me an unused parameter here, AC, meaning I declared a parameter but then I never used it. Now remember, arguments to main, it ought to take this is the standard, right? But then what if I never wanted to actually use my AC? I just wanted to use arguments to be my arguments to main method to get string input and then just display it to the user, or probably I'll use it to kind of do some operations in my program. This brings us to the concept of what void arguments. Now by void in C, we actually mean things that have no associated data type. I would like us to actually take note of it. Now if you are new to the channel, please give the video a like and do actually share it out to all ALX Quad 9 that actually undertaking this simple shell project. Alright, so let's quickly get back to it. Okay, so void argument void means what? Parameters, or basically they are just things with no associated data type. Now if you look at my IDX here, its associated data type is what? Int. My MSG here, its associated data type is what? A character. Now you see that in a program, or in almost every program, all variables have an associated data type. Now if I still want to get this done, but yet I want to kind of bypass this error there, I'll have to use that concept of what? Void, meaning I'll have to remove the associated data type of what? AC. Now how am I going to do that? Well, like I just said, simply just put in void and then AC and then my semicolon. But hey, a quick one, that's not all. I'll have to put in what? My parenthesis here. Now once I put my parenthesis here, it means that I want this guy to be evaluated first. I want it to be what? Evaluated first, because it's in what? Parenthesis. and this now has what a higher precedence. So I want it to be what evaluated first. Now with just this single addition, if I come in here, if I come in here and then I repeat that same command, now I just want to make it to be void, and then now you can see that I didn't get any error. Now if I'm going to run void and just say I'm just doing this, oopsie, I have to put this guy here. Okay, now you could see now from my previous video, you if you didn't watch our previous video, please go back so you could actually understand how we're able to achieve this. Now with even our previous video, you could actually go back and actually tackle your argc and argv project, because it's the same concept here. Alright, so now we've handled the part of what void arguments. Now we're getting string inputs. Now this is one way for us to actually get string inputs. This is one way, by using argument to main. Now another way you could actually do this is by using your scanf. You can actually using your scanf. Another let's just see the man scanf. Let me just go down. Now you can see, so the scanf function reads input from the standard input stream, which is std in, and we're just going to read from the standard inputs. Even this guy to fscanner reads inputs from the stream pointer, and then it saves them into the file here, because if you look at the declaration here, it's going to read and then save it on a variable, because it's actually reading that line. You ought to tell it where it's going to save it. So it's actually going to read whatever you are typing and then save it to a variable. Now how will scanf know when to actually stop reading? Well, it's when you're hitting your return key, or your carried return, or your new line character, or to some your EOL, which is your end of line. That's this your enter key. That's when it knows that okay, you are done reading, and then it's going to then save whatever it's being read into that particular variable. Now you should also note that when using your scanf, when you want to, especially when you are doing a string input, you must actually declare a size. You must actually declare a size for that particular variable. Now let's say your buffer now, or your bucket, let's call it a bucket. Now your bucket is actually going to hold like 5 liters now, and then you want to read, or then you want to fetch collect water, or you want to collect a liquid of 10. This, you see that you have buffer overflow as a matter of, but then what scanf is just going to do, scanf is just going to read that first 5 liters, or you're just going to take the first 5 liters and then completely ignore the other 5 liters. Now if you're going to use it to write a program, you realize that is not actually cool, because you actually have to declare a large size. Now what if that even size you actually declare is not even enough? Now let's assume I'm just thinking, okay, the user of this program is not going to enter characters above 1000, but then what if the guys type the user is actually sending in a poem or a book that's more than 1000 characters? You see that my program is no longer efficient. Now another one you could actually use to actually read string input is your getline function. Now it's still declared in your standard input and output library, which is your std header file. But now the interesting fact here is that the getline is actually going to read actually going to read from a file stream. In this case, it can actually be from a file. It's actually this guy here, it's a file, so it can read from a file. We should remember from our file tags or project, it could actually read from a file and also from a stream. Now let's assume I don't want to read from a file, which in this case we're actually going to be doing. I want to read from a string, like I want to read from my keyboard here. Just in this colon here, I'm actually just going to put what my standard input. That's just it. Okay, now let's kind of dissect what this getline is actually doing. Now this getline actually takes in 3 parameters. Now it's actually basically it has a slight similarity with the scanf, but then it's much more preferable. Then I'm going to explain, but then let's try and dissect the parameters here. Now the getline function takes in 3 arguments. Yeah, it's going to take from where it's going to read from, the number of bytes it's going to read, and then where it's going to save it. Or you could put your getline where it's going to save, the size is going to read, and where it's going to read from. I think that's easy for us to just put it on our head. Now, so you're allowed to use the getline function if and only if you include your stdio.header file. Now, how does it actually work? Now the getline function is actually going to read until you actually press in your carried return. Now please, I'm going to say carried return or your new line character. Please just know that I mean your enter key. Now it's actually going to read to report, pressing your carriage return, signifying that you are done reading, and then it's going to add the \n, which is the new line character, added to it. But in your scanf doesn't add the \n to it. It's only the \n only signals that you are done reading. But the getline function actually adds in the \n, and then it stops reading. Now the beautiful thing here in using the getline function is the fact that you necessarily don't really need to consider the size. Yeah, you don't really need to consider the size. Because why? Let's look at this. Because this guy here is actually a pointer. So the second parameter is actually a pointer to a size underscore t variable. Sorry, to a size underscore t data type here. That's signifying the amount of byte. Now, why is it actually taking a pointer? This is the reason why it's taking a pointer. Now, let's assume that when you declare your size or your bytes, now you declare 10, and then the user actually entered more than 10 bytes. Now actually entered more than 10 string, because you definitely know that characters are 1 byte, and white space too is still considered as a byte. Now if this user particularly then enters 15 characters, now in the case of scanf is just going to read that 10. But what getline would do, getline will actually still read that 15, but then how is it doing it? It's actually going to use a concept of realloc. That's why it's actually taking a pointer, because this pointer here that is taking is actually pointing to where you declare the size, and that's why you have to declare them separately. So when it reads 15, it's actually going to change the number of bytes there in which you read. But what I've come to that's actually the concept there, because if you're actually going to read this whole part of it there, you actually get the gist. I think it's somewhere here. Let's see where it's actually. I think it's somewhere here if we actually take our time to read it. It's somewhere here. Okay, it says alternatively, before calling getline, the operator can contain a pointer to a malloc allocated buffer n bytes inside. If the buffer is not large enough to hold the line, getline resizes it with what realloc, updating line ptr and n as necessary. But then what I've that's just the gist there. But then what I've come to realize by using the getline function is that even if you pass in 0 to it, it's just going to actually allocate like a first 120 bytes to it. Now if the user actually enters more than 120 bytes, it then allocates double, which is 240. Now if the user enters more than 240, it then at this point that it doesn't double again, then I think it triples. I really can't remember when I tried practicalizing it, but then I realized that when I actually used it without passing in a size there, by just putting 0 and reading a large number, the buffer there came out to be 120. That's the size of the buffer. Then I actually exceeded 120. It came out to be 240. Then I actually exceeded 240, and then I actually got a large number. So that's basically how the getline function. So you see that you are always safe when you use the getline function, but then it's actually going to return sorry about that. It's actually going to return an s size underscore t data type to the called to main, or to the function that was actually calling the getline function. And this here is going to contain the number of bytes that was read. Because actually see it from the return value here. Says will return the number of characters read, including the delimiter character, but not including the terminating null byte. It's actually we should take note of that. It's going to return the number of characters that it's read, including your delimiter, then but not including your terminating null byte. Okay, so now let's think I have another terminal here. So I'm just going to do getline here. Okay, so then I can exit here. So let me just do this is too long. Do getline.c. So the only requirement here is I have to include my stdio.h. Okay, now for me to actually use this, I have to main first. Now the reason I'm not actually talking about much about our scanf function here was because scanf is not part of one of the required functions for the simple shell. It's actually what getline. So I'm basically making this explanation to be in line with the project requirements here. Alright, so the first thing here is I have to do actually declare okay, I forgot to quickly note, it's advisable that this should actually be gotten from what this buffer size actually be gotten from what your malloc, because since if it's more than it's actually going to reallocate it using what realloc. Now we should know how our realloc works. So since it's actually, if this here it's more than, if this guy here, if what is being read it's more than, it's advisable we just get it from malloc, because you don't want to be using your stack memory and then passing it as a pointer to realloc. It's going to result in program crash. So I'm just going to say, let me just call this my buff as my buffer. For now I'm just going to pass in null. Okay, now the next thing I will need, according to this guy here, and you should please note that this here is means that it's actually taking a pointer to a string that's actually gotten from using calloc, sorry, from using malloc. It's not that if you actually do something like this, now, and you say probably 50, just as though you are using your the way you use your scanf, and actually do this, it's not like it's not going to work, but then you're kind of limiting it to work like a scanf, because it won't be able to reallocate it. It's going to result in a program crash. So it's advisable you just get it using what's your malloc function, or you could use calloc in this case, anyone. So I'm just going to first say that this guy here, it's no, yes, that's basically there's too much. Now the next thing here is I have to declare what is size. I have to declare this variable here to be what, let me call this one my bytes. Let me call this my bytes. Let me just say this should be 10. Okay, now that's the only thing I need from to actually read input from the user. Now the first we actually thought about that was using what our command line argument, using argv actually. Now we're actually considering another way. Now if I'm going to call in my getline function, I could actually just call my getline function directly. You'll see my getline. Then remember, I'm passing the address of my buffer here. I'm passing the address of my buffer. Then I'm also going to pass the address of what, my bytes. Then I'm saying I want to read from the standard input, but then I first need to actually what, get an address first for buff. So if I'm going to do that, then I have to include the standard library. Okay, now you can see the way we're actually talking through the process, and we are only including things we need per time. Okay, good. So now I have actually included my standard library. I could then come in here and say buff equal to malloc. Let's just say malloc, then size of char, and just malloc this to bytes. So basically I'm actually saying malloc, give me malloc 10 first. That's basically what I'm saying here. Oh, sorry about that. Okay, so now I have to actually pass in a check condition. So I could say if my buffer, then let me just make this beginner friendly. So I can just say if my buffer is equal to no, then I want to then make this very precise and interactive. So I could just say malloc failed. So I will know the reason for it. I could just say malloc failed to allocate memory. Then I want to just return, because if this guy here if this guy is not able to get a memory for this guy, there's no point in me reading, because it's actually, this guy is actually going to read it into this. So it's just better it actually stops here and then it ends, because if it's going to show this, therefore means that there was no space allocated in the very first, so this effort here is just going to be fruitless. Okay, so after reading from my standard input, I then just want to print, it. Then want to just print, I could say let's say the string enter this put in my new color, let's say buff. Okay, then we will give space so we could actually read it, so it's actually be beautiful to read. So as a quick summary, we are declaring a buffer, a variable called buffer, and then we are getting is an address from the heap to be stored in the buffer, because we actually said it's a pointer, so it's definitely going to accept what an address. So, and malloc is going to return an address. So cool. Now we're actually saying if malloc has failed, then it should print out this. Then I'm just going to read from it and then printing. So that's just a quick summary here. Oops. Okay. Man, I don't want this video to be long, so I can just say gcc getline.c. Then let's just say the output file should be line. Yep. Okay, so I could then run line. Oopsie, I made it. How to display prompt here. Okay, I could just edit it. Okay, the enter string is Sammy. Okay, so let me just come in here and edit it. So just going to come in here and then do something like this: printf. Okay, I could just say, okay, let's just make this a prompt. I could just say Sammy. Okay, this is what I did during my own shell project. I then did something like this. Then this is what I did on my shell project. Now, since the getline function is going to add in a new line character to my string, there's no point in me putting this \n here. So now it's going to look like, that's the reason why you're actually seeing it in another space here, because after reading Sammy, it added the new line here, which I actually said as my carriage return. So it added it here, of which it forced it to the next line, and from my printf again, the new line character there, of which forced it again down there. So that was just it. So I'm just going to do gcc again. Oh damn. Okay, now you could see it's actually looking like we're actually getting to do our shell. Actually looking something like that. Okay, now in this case, let me enter more than the 10. Yeah, let's just say this string is definitely more than 10. You could see it read it, and it actually was printed it out here, of which what we actually declared here was what, 10. I can put here to be 0 too, and it's still going to be the same. but then I want to, now you could see I'm not, this getline function is actually returning something, but I am not actually using, I'm not actually using it, because it's returning something here, but then there's nothing collecting it. So what if I want something to collect it? Let me just then come in here. First, let me give it space. Then let me come here, and then it have to be of this type here. So you can see you could just notice that I'm actually following on the process here according to the prototype. Okay, so then I could then say, what should this be? What should be the variable name? Yeah, I could just say be read. So this should just be the number of bytes read. Then I could just say this should be 0 for now. Then I could then put be read here. Then I could put be read here. Then I could, and then can come in here, then put in another printf statement and say number of bytes read is actually an unsigned integer. Then a new line character here. Now I'm not putting a new line character there because I have actually explained why, but yeah, I'm reading this guy, so I just have to put in my \n there. So I just have to call in be read. Okay, and yep, we're done. So now let's go. I'm just going to copy this so to prevent me from typing again. Oh, okay, yeah, that's true. Oopsie. Because this guy here is actually a larger size of this guy, yeah, but they are of, well, both are what, unsigned integers. Okay, I'm just going to come in and change it to LD. Oopsie. This is more than 10 bytes. Now you can see it actually what returned what 27. That means if you're going to count this here, you see that it's actually what 27. So it's actually what is read here. Now let's see the size of, because since it's actually going to use realloc, now let's see the size of our bytes. Now you can actually do that. You can actually do that there. Let's come in here and then print new. Oops, sorry. Let's do that, and let's come in here just here, and then let's say new bytes. Let's say new bytes. Come in here, then I'll have to read bytes. Okay. Oh, this, I don't know, I'm always forgetting this. Pardon me. This is more than 10 bytes. Now you can see what 28 here. You can see what 28 here. Now I didn't put in the \n here, when that's why it's actually still reading what it's actually still putting my prompts here. and you could see here now, you could see here that you try 27, but then you see 28 because of the \n that actually automatically added to it. So okay, so that's that about yeah, this it's already getting long. So that's that about using getting string inputs and basically our getline function. So now the next one we'll be talking about the string splitting, where we'll be using our strtalk on your string tokenization function. You can actually even start reading about it if you do this. If you actually do this, you can actually see. So just the same way we're actually able to explain this guy here, you could actually just use this concept here, and then you just use it with your strtalk function, and then you are actually good to go. Please do try and give the video a like, and also share it out to all ALX students that are actually going to undertaking the simple shell. I really hope I'm actually going to have the time to actually complete this. I really do hope that. All right, thank you very much, and God bless you all.